Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series Advanced Development in Grasshopper. In this video, we're not going to code a lot actually, because what I would like to teach you is the difference between the two main file formats that Grasshopper can save to, and what are the advantages of one and the other, and when should we decide to use one versus the other. And what do I mean by this? So let's start with a very simple example. Let's say that I'm going to create a slider that goes from 0 to 10. And literally, that's the only thing I'm going to have in my Grasshopper definition, all right? I'm going to rename this as slider name, and I'm going to set the value to whatever, okay? That's it. That's just my entire definition. By default, if I were to say, I want to save this document in my computer, and I'm going to save it to some folder called Parametric Camp, for example, and I'm going to call this slider. You can see that by default, what Grasshopper offers me is to save this file as a Grasshopper binary, or with the extension GH. If I do that, which is the standard, is the default, is what you get if you don't specify anything, and then if I go to this folder, you can see that now I have a file here called slider.gh. If you don't see the GH, it's maybe because you have configured your system to hide extensions for known files. So I recommend that you view, you disable, what is it called? Hide extensions for known file types. It's always nice to see the extensions of the file, especially if you are in the hacker programming side of things in your life. Anyway, so you can see that this file is now Grasshopper GH. And what this means is that this file has been saved as a binary. What that means is that Grasshopper, when it saves definitions, the definitions are internally saved in this format that is called XML. XML is a structured file format where the data and the properties that are stored are basically saved in a hierarchical way. But because this has been saved as a binary, what Grasshopper does is that it takes that XML file and it compresses it with a particular algorithm, and then it turns it into optimized zeros and ones. What that means is that this file is very optimal as space saving, so it's much lighter on your memory-wise on your computer than the original XML file would be. But the problem with that is that if I were to try to now open this file on a regular text editor, for example, this one, I would basically get gibberish. I would get something that is not understandable. This is mostly Chinese characters for some reason, but I don't think that these Chinese characters actually mean anything. If I were to open this, for example, on a code editor like Visual Studio Code, you can see that the file, it tells me that it can't be opened because it's either binary or unsupported. So if I just open it anyway, you can see that I get these like weird characters that are basically unintelligible for a human. This is because, again, this original XML format has been compressed using compression algorithms so that it's a bunch of zeros and ones that save a lot of space, but cannot be read as characters in a text editor. All right? So what Grasshopper gives us as a possibility is to, instead of saving in this binary compressed optimized format, we can save the file in the original. Let me go to save document as. We can save the document in the original file format XML with the extension GHX. What that means is that this file, now I'm going to call it the same, slider.ghx, and you're going to see that in my computer, now I have two files, the Grasshopper file and the Grasshopper X file. You can see that this one is 4 times larger memory-wise, right? But the nice thing about this one is that if I now open any text editor and I drag this file in there, what you can see is that I can see actual human code. I can see letters, text, and I can kind of understand what's going on, more or less, all right? There's a lot of data here, but at least the data has been saved in a text format without optimization, without compression, etc., that can be read very easily by any text editor or by any script or any algorithm that you write that does text and string manipulation. All right. I've been using Notepad to represent any generic text editor, but I'm going to be using actually Visual Studio Code for this tutorial, because if I now drop the GHX file here, you can see that what I get is nicely color highlighted representation of this file, because since Visual Studio Code is a text editor, it understands that what I'm reading is an XML file that has a particular format, a particular set of standards, and is able to highlight with different colors the different things that are part of this file. Okay? Now, this is great because what this means is that the Grasshopper definition that we have here, which is just this one slider, actually has a sort of, it's not really exactly code, but it has a structured data representation that is parsable with strings and with any machine. What that means is, if we look closer here, we can see that it's an XML file. And an XML file, in a nutshell, you can Google this, but in a nutshell, is basically a file that has pairs of tags. So for example, anything that is opens with an items needs to be closed with an item. Anything that is opens with a chunk needs to be closed with a closing chunk here, etc. Everything that opens with an ARGB gets closed with a closing RGB. This character here, the / means closing the tag. And then information is wrapped always between opening and closing tags. And where these tags are, whether if they are inside another group that opens and closes some other tag, is this hierarchical nested way of representing data. This is very useful because it's very easy to do machine parsing with this kind of information. For example, some things that we can learn about this file. There is an item that has the name archive version of Grasshopper, and we can see that this file was recorded with major version 0, minor version 2, and revision version 2. So that's 022 is the version of the archive that this file is using. The plugin version, I think this refers to the Grasshopper version, is 107. Okay? Then there's a header that specifies a bunch of things. So for example, the color of the preview, this is in format ARGB, so 100 opacity, and then or transparency, and then 15000, that is like a medium red, right? Whereas preview selected, it's an RGB color which is half transparent and has 0, 150, and 0. So that's like a middle green, all right? So we can see that when we open a file, the preview colors are actually part of the file. They're not part of your general Grasshopper configuration, which is kind of interesting as well. Properties of the file. Well, the projection where the file is looking right now in XY, the zoom level of the file as well, how many views it has, and this, which is arguably the most interesting part, the definition objects. So how many objects are part of our definition? And you can see, if I wrap the files, you can see that there's only one object, and that this object is of the type number slider. It has a bunch of attributes, description, the name, the nickname, and the nickname is the one that I wrote, slider name. And it has a bunch of attributes. So for example, where it is in the definition, so the X, Y, the width, and the height, and then another bunch of definitions, such as, for example, how many digits, how many decimal digits, what is the interval, the maximum value, the minimum value, and the actual value that the slider is set to. Okay? And last but not least, a thumbnail representation. So this is a string representation of an image with a particular encoding. So that is also, you can see that also Grasshopper files embed a tiny thumbnail inside of them. So I find this extremely interesting because if we can save Grasshopper files in their original uncompressed text format, then that gives us the possibility of doing a lot of really interesting things, such as, for example, using machine code, using computer programming to do parsing of these files and, for example, retrieve information about these files. So what we could do is we could write a script that goes through a folder of Grasshopper definitions, and it looks at every definition and it figures out how many components a definition has. We could do that with machine code. Or, for example, let's say we want to change the location of our components for some reason. So we could just look at the XY of all the components and maybe like move them around, like push them away, or like just compress everything into one single point. So we can do this kind of procedural manipulations. So, and actually, before I move on into describing pros and cons of each kind of format, let me actually show you an example of some kind of manipulation that we can do on Grasshopper XML files. So let me show you an example. So for instance, let me show you an example of this. So this is the Grasshopper Sharp project. It's a project that I worked on and that I maintain with a set of open source community people that have helped me make this. It's basically trying to reproduce with C# scripting as many of the original vanilla components. I think it's a nice, fun project to do. But anyway, so and a link to this repo should be popping as a card here somewhere, and there will be a description to this, a link to this also in the description of this video. So if we go to source, what we can see is that basically we have a few folders where each folder represents one of the tabs that we have here in Grasshopper. So either vector, curve, surface, correct? And then if I go inside, for example, curve, you can see that we have one file per each one of the tabs that we have for the curves family. So analysis, division, primitive, whatever, etc., etc. And as you can see in this project, these files are saved in Grasshopper X format. I will get to why this is the case very soon. But for example, if we click here, what this means is that, well, this file is a little too big, but I can actually see it. And you can see that I can see on GitHub the actual code of this file, the XML representation. All right. So if I were to copy and paste all of those files here in the folder that I'm writing, that I'm working on, and for example, I can drop the curve analysis file here, you can see that if I zoom out, what this file is basically trying to do is reproduce all the curve analysis components using C# scripting. So for example, is the curve closed? So I double click here and I have code that does the exact same thing. We've talked about this project in other parts of this channel, so you're welcome to check it out and use it to learn some more C# techniques inside of Grasshopper. Anyway, but you can see that one of the things that we do in the project is that whenever one of the components is not fully well implemented for some reason, certain parts are missing, or we couldn't reproduce the full functionality, that group is grouped with this kind of orange group. All right. And you can see that particularly in this file, there's a bunch of these orange groups, right? If I go to Visual Studio Code and I now open the curve analysis file, you can see that it's a very, very large file. It has like thousands of lines of code, like, 28,000 lines of code. And there's a lot of components all the way around here, and so actually breaking these definitions, these XML files down manually is actually it's not complicated, it's just tedious because there's so much stuff and so much information. For us humans, for a machine, this is extremely, extremely easy and fast to do. But one thing that we can do, for example, is that we can just Google, we can just try to find in the file the word group. And you can see that here we have a group of Grasshopper objects, which means that this XML here is the one, this whole thing here is the one that is representing the group in a definition. And you can see that it has a bunch of properties. For example, it has the GUIDs, or if you want, the signature of the components that this particular group is grouping, so that when we open the file, the group can just wrap all these components together. But something that it also has is the color. So you can see that the color here is an ARGB representation of that is an ARGB representation of the color that is used for the background of that group. Okay, so let's say that instead of going manually to each, let's say that for some reason we don't like this orange color, and that instead of going manually to each one of these and changing the color and blah blah blah, which is 255, 191, 145. Did we find it? Oh yeah, we found actually one of the orange groups. That's great, right? So let's say that instead of doing this manually, going to each one of them, changing the color, etc., and then doing the same thing for all the orange components, we wanted to do this programmatically. Something that we could do is we could write a small script that goes through the text in this file and then finds this particular sequence, the ARGB color that we can change, that we want to change, and we can replace it with a different color. All right, that is actually very doable. So how are we going to do this? Well, just for the sake of making things easy, we are going to use, that programming language that starts with P, just because it's kind of easy. And because for those kind of like banal, trivial manipulation things, it's actually a pretty good programming language. So we're going to write a Python script to parse through the text in this file, and then trying to find a particular string sentence and replace that with another string. Okay. So how are we going to do that? I'm actually going to be copy pasting from an example that I found online from author Pippery and Shiram, all right? And which is a very simple Python script to replace a string of text in a particular text file, all right? So how are we going to do this? Well, I'm going to create a new file. First of all, I'm going to open a terminal here in the folder where my files are, all right? So you can see that I am on my desktop on the pcam folder. And then I'm going to create a new file by typing code. And for example, replace.py. All right. What this is going to do is that it's going to open my Visual Studio Code with this new file that I've created. And as soon as I save it, you can see that it shows up in my folder as replace.py. All right. And for example, I can say print hello there. All right. And then I save this file, and then I can run Python replace, and then I get a printout here in the console. All right. If you don't know Python, or if you don't, it's fine. You can look at some tutorials out there. The purpose here is to make just an example of how we can replace strings in a file. All right. So what I'm going to do is I'm going to copy and paste this text. I will probably have the link to this question somewhere as a card or in the description of this video. All right. And I'm just basically going to copy and paste all of this here. All right. What this file does is it imports a bunch of system modules to do manipulations with files. And then it asks the user, what text do you want to search? What do you want to replace it? And which one is the file? And then it does a simple manipulation where it opens the file, it goes line by line, and if it finds this text in the line, it replaces it with the text that we set. All right, I'm going to save this, okay? And what are we going to do? What we want to do is we want to find this color, the orangey color in the file, and we want to replace it with something different, for example. So I'm going to run Python replace. All right. And what is the text that I want to search for? I want to search for this orange color. And I'm actually going to use the full XML representation with the text. All right. That is the text that I want. And now, what do you want to replace it with? So I'm going to replace it with something similar that is going to be perhaps like greener. So I'm going to do full green channel and I'm going to crack this down to 100, for example. So I just don't know what color that is, but let's say we knew this because we had an RGB swatch or whatever, okay? And then what is the file that I want to do replacing on? So the file is going to be curve analysis. So I'm going to go here, I'm going to copy the route. So the file is here, and then it's called curve underscore analysis dot GHX, okay? As I do that, then it's going to print out a lot of stuff on the console. But you can see that this file in my Visual Studio Code already updated to this new color, okay? What that means is that if I go to Grasshopper, Grasshopper doesn't have those changes because the Grasshopper is not reading the file continuously. But if I close this and then I drop this file again, we can see that now, ta-da! All the colors are now green. Whoa! How cool is this? I changed the color of these groups programmatically using a Python script. Okay, but you see the point. It's actually quite easy to do massive changes, procedural changes on a file just by doing simple string manipulation. You could say, well, Jose, like you weren't very clean because you basically just used the color string. So if there was any other object, like for example, a panel or like other groups, whatever that share the same color, you would have replaced it now and you would be right. I was like very, very specific because in this case, I knew that it's just the groups that have the orange color. But you can get more sophisticated. You can write better scripts that actually look at the XML. You can actually use libraries in Python that read XML formats and parse XML format and then do smarter manipulations based on that. But we're not going to get into that because that's not the point of this tutorial. All right. So the question now would be, when do we use one format or the other, right? So I think it's actually quite easy. So first of all, if you are just developing stuff, simple Grasshopper user, you're just saving your files and you really don't care about much, then definitely stick to the standard format, the binary one, just because it's going to save you a lot of space in memory. It's like somewhere between 4 times and 10 times the footprint of the file. It's actually kind of ridiculous, the compression of just simple plain text. So, however, you may want to consider saving your files in the XML format if, for example, you are expecting to do some kind of mass analysis of files. So you have a large collection of Grasshopper scripts and you want to write a script that changes your author name in all of them, or you want to see what is the average amount of components that you use for each one of your definitions, or you want to write some machine learning algorithm that learns from the representation, whatever that is. If you want to do parsing with other means of large sets of Grasshopper files, then definitely having those files in the XML format is actually quite helpful. Similarly, if you are writing Grasshopper definitions and you're versioning those definitions in some kind of version control system like Git or like Subversion, then I would definitely recommend that you use the XML file format because binary files cannot be versioned in Git, for example. If you have a binary file that gets saved and zeros and ones, and then you change something in the file and save it again, basically the full file is saved with the new commit. What that means is that every time you commit something, you're basically forgetting about the old file and you're saving all the information of the new file. And that over time will accumulate into a Git project that is extremely large. On top of that, it kind of defeats the purpose, because the whole purpose of versioning is to be able to see the differences between the version that you had before and what changed in the new version. And because when you save a file as a binary, basically all the zeros and ones kind of change based on the compression, then it is impossible to do that with binary files. However, if you save your files in a format that is easy to read as text, then version control systems can see the previous version, can compare it with the new one, and then they can tell you the difference. So for example, that is the reason why in the Grasshopper Sharp project, we had all the source files, we had them saved as Grasshopper XML files, so that when I open them, I can see the raw file, or I can go and see, let me see the commits list. Oh, I can see that the last file that was changed was the freeform surface one. And you can see that there was a lot of changes. There were a lot of changes, like 3,000 changes. So I'm actually loading the changes. And you can see that Git is able to tell me that, well, the position of this component changed, the zoom level of the file also changed. Like for this particular item, we removed this one and we added 3 more to the group, etc., etc. So I can kind of see the differences between the files, but at the same time, the way this is saved in the Git project is much more optimal. All right. So if you are saving if you have a Grasshopper definition that you're versioning, then I really recommend you use the Grasshopper XML file. Okay. However, unless this is a GitHub problem or a versioning problem, if you want to do massive changes, if you have a large collection of Grasshopper files and you want to make massive changes or like procedural changes, and you just so happen to have all those files in regular binary format, that is fine, because it turns out that because the binary file is basically just a compressed version of the XML file, going from one or the other is actually quite easy to do. It's just a matter of compressing or decompressing the file. And there's actually projects out there, so as like, for example, this project by Ruffle, which gives us a command line tool that allows us to programmatically or with code change large amounts of files from Grasshopper to Grasshopper XML or vice versa. Okay. So I will post a link to this project as part of these cards, as a card here on the video or in the description of this video as well. All right. And yeah, and that's pretty much it. I find peeping through the XML actually quite interesting, and sometimes it's also very helpful, because sometimes when we do some kind of manipulations of files, we actually need to know what is the GUID of some components or the global unique identifier of that component, and we can actually very easily see those as part of this file. So taking a look at the file is always kind of interesting as well. All right. Beautiful. With this is as much as I wanted to say about this topic, and we are ready to move on to the next video in this series. However, in the meantime, if you found this useful, if you liked the content, then maybe consider liking this video or subscribing to the channel, and all those things YouTubers do these days. Thank you very much, and see you on the next video.